Dear students, welcome to a new video for the language course. Now we will begin to a new non-parametric test, which is Kruskal-Wallis test. We already in the chapter take 5 other non-parametric tests that these tests used when we can't apply the parametric test and the case is not normally distributed. So we should use another tests to get our hypothesis. Now we will use the Kruskal-Wallis test. When we have the analysis of variance uses of f-tests compare means of 3 or more population, where the assumptions of the ANOVA table test are normally distributed, we use, of course, the f-test. But if it's not normally distributed and assumption can't be met, what we can do? In this case, we use the Kruskal-Wallis test. The Kruskal-Wallis test, sometimes called H-test, because we apply H formula for it, and can be used when we compare 3 or more means, instead of the F-test in the case of the parametric tests. In this test, we have samples, maybe 3 or more, but each sample size must be 5 or more inside each sample, so we have 5 or more variables. Now, we can't apply the test for no more than 2 samples or more, but inside each sample we have sample size 5 or more. In this situation, the distribution can be approximated to a chi-square distribution with k-1 degree of freedom. So when we get the critical value and the tabulated value for the Kruskal-Wallis test, we use chi-square table, and we use a degree of freedom k-1, where k is the number of groups, number of samples that we have, number of samples, not the sample size. It's different. Please concentrate. This test also uses rank inside it. So we will use the tables for chi-square and degree of freedom k-1, and we will rank our samples in this test. The formula for the test can be given here, and the Kruskal-Wallis test consider all the data in the values of the groups, and we use rank to get the values inside the ranks and not excluding any one of the data. Then we rank the ranks are separated and H formula is applied. The H formula is the formula for the rank of the Kruskal-Wallis test, and this formula can be approximated when the variance of the ranks. If the samples are from the different population, the sum of the ranks will be different. Of course, it's if the samples from the different population, of course, the sums of the ranks will be different, and each value will be large. And in this case, the null hypothesis will be rejected. So we use this rule in the fourth step, which is the decision step. If we find that the critical value or the value that obtained from the table is large because the difference in the values of the ranks, so and each value of the formula for the Kruskal-Wallis test is very large also, so this null hypothesis will be rejected if H is large enough. If the samples are from the same population, so the ranks will be approximately the same and H will be small. Therefore, the null hypothesis here will not be rejected. Simply, you apply the H formula for Kruskal-Wallis test and compare it with the values for the table from the chi-square table, and if the value is very large, and when the values will be large when the population come from different samples and the variance and sum of ranks very large, but the values may be small when the sums of rank and the samples are from the same population, and the sum of the ranks will be the same, so the H will be small. Again, we have two different situations. The H will be small and H will be large. So if it will be small, the null hypothesis will not be rejected because this means it may be the same and we have equal. So it's the equal hypothesis not be rejected. But it is very large. This means there is the variance of the ranks vary and very large, and the samples are from different population. So in this case, we will reject the null hypothesis. The test is always right-tailed, it's not left-tailed, and the chi-square table in your book in the appendix table D will with degree of freedom k-1, where k the number of samples should be used to get the critical value or the tabulated value. Here is the Kruskal-Wallace formula, which is called H formula, equal to 12 over n times n plus 1 multiplied by r1 square over n1 plus r2 square over 2n2 plus all r the square over n r square up to r square k over nk minus 3n plus 1, where the r1 is the sum of the ranks for the sample 1 rank, so we will use the rank. R2 the sum of the rank of sample 2, Rk the sum of the rank of sample k. Also, n1, n2 up to n small nk are the sample sizes, and capital N is the total number of sample size. Here, capital N equal to n1, n2 up to nk, and k, of course, is the number of sample as mentioned before. Now, let's take an example. Milli-equivalent of potassium in breakfast drinks. A researcher tests 3 different brands of breakfast drinks to see how many milli-equivalent of potassium per quart each contains. These data are obtained. Here we have 3 brands, and the researcher wants to test how the milli-equivalent in each brand per quart. The 3 brands are there: brand 1, brand A, brand B, and brand C, and these are the values in each brand. At alpha equal to 0.05, is there enough evidence to reject the hypothesis that the all brands contain the same amount of potassium? How hey, all the values want to be ranked together because we said that the test uses the rank to get the hypothesis. Now let's apply the 5 steps for the hypothesis testing in the same way. Step 1, we state the hypothesis and identify the claim. We have the null hypothesis and the alternative hypothesis. Null hypothesis that there is no difference in the amount of potassium contained in the brands. This means that the 3 brands have the same amount of potassium. And this is the claim, because if you recall the claim, he wants to test is the 3 brands are equal. So our claim here in the null hypothesis, not in H1, not in H1, and the H1 hypothesis tests that there is a difference in the amount of potassium contained in the brands. So this is the first step, so state the hypothesis. The second step, which is finding the critical values. The critical value here we will use the chi-square as mentioned before in the test and the appendix in your book in table D, with degree of freedom k-1, where we have k is the number of groups. How many samples or how many groups we have in this example or in this situation? We have 3 brands and 3 groups. So with alpha equal to, or the degree of freedom equal to 0.05, and the degree of freedom for the chi-square test equals 3 minus 1, which is the number of groups minus 1 equal to 2. So we will go to the table for in the appendix D in your book and find the critical value that's associated with degree of freedom 0.05 and df equal to. We will find the critical value equal to 5.991. So in this step, step 2, we get the critical value or the tabulated value. Now we will move to the third step for the critical Wallace test, which is computing the test value by using the formula for the test as we mentioned before, that h equal to 12 over n multiplied by n minus n plus 1 times r squared 1 over n1 plus r squared 2 over n2 r squared 3 over n3, because we have only here 3 groups or 3 samples, minus 3, which is the number of samples or groups, which is equal to 3, and multiplied by n plus 1. Here from this formula, we want the values for r, which is not given direct. So we should rank the 3 samples. Again, go to the table given that we have brand A, brand B, and brand C. We will arrange all the data from the lowest to highest according to the values given. So the lowest one were 3.2 and coming from brand A. And you should write this column that's from what this amount comes. This from brand A or brand B or brand C, because you will need it in the step P. So after ranking or after getting the value, write the column beside where from what is come from, which brand. The other value 4.7 coming from A and 5 coming from A. Here 5.3 coming from brand B, 6.2 coming from C, and so on. So you, in the first column, you should arrange from the old data from the lowest to highest, and in the second column, write from which amount from the data get from which brand. And then in the third column, you write the rank. And because there is no two amounts equal, the rankers take the values 1, 2, 3, 11 to 15, and not two numbers divided by 2 or 3. This is the rank is direct. Of course, you are now qualified enough to have to get rank, and you practice in the other tests how to rank any amount if they are repeated. Of course, again, if the amount is repeated, we take the ranks, say the rank 4 and 5. We add the rank 4 and 5 and divide it by 2 to get 4.5 and 4.5, and then take the next equal to 6. But here in this example, the rank is direct because no amounts are repeated. Now we will move to the step P and rank sums for the each brand alone. I mean, we will look at the brands column and get here what the rank is for A. We find it for the ranks for A equal to 1 plus 2 plus 3 plus 4 plus 5, and more ranks for A. No is here. So we add the sum of the rank A equal 1 plus 2 plus 3 plus 4 plus 5. If we go to the rank sum P, sum the rank P here 6 and 9 and 11, 13 and 40. So the brand P, the sum of the rank equal to 53. Finally, brand P, sum the ranks for brand P. We find it's 7 plus 8 plus 10 here, 7 plus 8 plus 10 plus 12 and finally 15. So the sum of the rank 3 equal to 52. Of course, each brand have 5 values inside or 5 variable inside, so we have 5 in each summation and the total of sum of the each ranks are given here. Now we have the values for the ranks. Just substitute in the H formula or the formula for Crooksville-Wallace test. So we have R1 equal to 15, so we will have R1 squared over N1, which is the sample size for the first brand, which is equal to 5. And R square 2, R2 square equal to 53 square over the sample size N2, which is equal to 5 also. Finally, R3 square, which is the brand ranks for sum for the rank for the brand 3, equal to 52 square over the sample size for the brand C equal to 5. Minus 3, which is the number of groups or K. Here we have 3 samples or 3 groups, so K will be multiplied by the total sample sizes, which is capital N, which is equal to 5 plus 5 plus 5, all the sample sizes, plus 1. Here, use your calculator to get the value for the Crooksville-Wallace test or H formula, which is equal to 9.38. And this is the third step for getting the test value. Now we have in the second step a tabulated value, and in the third step a calculated value, and in the fourth step we will make our decision upon these two values. Since the test value here 9.38 is greater than the critical value, the decision is to reject the null hypothesis. Because the calculated value is greater than the tabulated value, and we will reject the null hypothesis, and that this means that there is enough evidence to reject the claim that is no difference in the amount of the potassium contained in the 3 brands. Here, the Crooksville-Wallace test is very easy test. It have a less step than the Wallace test. Please practice more for this test, and you have here another example. Solve it and practice more in your book. You have many exercises on this type of situations and problems. You can easily apply the formulas and take more qualifications when you study yourself, not just look to a solved example. Please try to answer yourself. You are doing a research on an article on the waterfalls on our planet. You want to make a statement about the height of waterfalls on 3 continents. The 3 samples of waterfall height are shown. So we have 3 samples with the different values. You now will rank them and get the tabulated value from the appendix D in your book, and get the calculated value from the Wallace Crooksville test, and then compare the 2 values and get your decision. But there are about questions on here on this situation or this example before you start to apply your test. The question is, what's the questions you are trying to answer. What is the non-parametric test is used to find the answer. What are the hypotheses? And select the level of significance and run the test. What is each value? What is your conclusion? What is the corresponding parametric test? What's the assumption you need to make your conduct test? Here, these questions may be not for testing the hypothesis in the data. You will, after answering these questions, begin to get your answer about the hypothesis testing and applying the test. These questions from 1 to 7 just for studying and how to apply the concept for the test, not for just applying in the rule and getting the values, just to how to make a sense for the test and get it that how to conduct the test, not how to apply the formula. So after answering the questions from 1 to 7, try to solve it by using the steps of the hypothesis testing. Thank you.